Hello. Today we're going to be discussing washing and extraction. Washing and extraction, two different ways of looking at the same separatory technique. In both cases, a mixture of compounds dissolved in one type of liquid are going to be separated between two different liquids. For this reason, the name of the device we are using is the separatory funnel, or SEP funnel for those that know. Now, the two different liquids we are using, so they can split into two distinct layers into which our compounds will be divided. Those layers are usually an aqueous phase, comprised of water, and an organic phase of some organic compound like diethyl ether or methylene chloride. Which layer is on top and which layer is on the bottom is strictly determined by the density. Today, we are going to try to separate indigo, the dye used in coloring blue jeans, and tranexamic acid, which is derived from ethyl cinnamate, one of the major flavoring compounds in the cinnamon we know and love. So how exactly are we going to separate indigo from tranexamic acid? Initially, both indigo and tranexamic acid are going to be soluble in organic solvents. Both of them have large conjugated regions, and in the case of indigo, there is internal hydrogen bonding, which doesn't facilitate bonding with water molecules. So initially, both of them are going to be soluble in the organic phase. However, both of them can be made to be soluble in water. But the way of doing this is orthogonal for both molecules, and that's what's important here. If we were to mix this organic phase with a basic solution, then we could deprotonate tranexamic acid to make an anion, and it would then be soluble in water. Like that. This, of course, would do nothing to the indigo, which cannot be further deprotonated by a mild base. In the opposite case, if we were to wash this organic layer with an acidic solution, then the indigo could be protonated at either of these nitrogen atoms to give a cation, which would make it soluble in water. This, of course, would do nothing to the acid, which is already protonated. In this way, these two compounds can be separated. That is the theory. Let's see how it works in practice. I'm going to dissolve both of these compounds, now separated, into ether together, so we can then separate them again. Okay. I now have a mixture of indigo and tranexamic acid in this ether. I'm going to pour it into the separatory funnel. Before you pour anything into a separatory funnel, you should make sure the bottom is properly stopped. If this is vertical, that means this is open. It's horizontal. The stem to the separatory funnel is closed. Again, I would have you do this in the hood. For demonstration purposes, it is out here on the counter. Now that we've combined these two compounds, how can we separate them out again? I've decided to use sodium hydroxide. Very strong base. Stronger than is needed to deprotonate tranexamic acid. This means that we will be taking tranexamic acid into the water and leaving the indigo behind in the organic phase. Because water is denser than ether, if we pour water into this sep funnel, it will go to the bottom of the sep funnel. Now, what makes this washing or extraction? All that matters is what you want to keep, what compound you're trying to isolate. I am going to remove tranexamic acid into the water layer. If the compound I want to keep is indigo, then I am washing the indigo with water to remove tranexamic acid. If tranexamic acid is what I want to keep, then I am extracting tranexamic acid from a solution with indigo. So really, the only difference between the two terms is what target you wish to achieve. Okay, I'm now going to move to the hood